Great to be here. See folks still here in the last session of the day. So this conference is, I really didn't notice this time I was making my title slide that the conference was primarily about soil health, but I'm really not going to deal with soil health so much. What we've been after in Chesapeake Bay is really about water quality. I think soil health goes along with that a little bit, but I'm going to be focusing mostly on using winter cover crops in the Chesapeake Bay restoration effort. But it's certainly great to be here. So the main problem in the Bay, anybody knows about water quality issues in ag or people in general. Excessive nutrient inputs are basically driving algal growth, and we have low oxygen levels, dead zones. You know, we have a dead zone in, I think the estuarine scientists in Gulf of Mexico are arguing with the ones in Chesapeake Bay about who coined dead zone first, you know. But anyway, that's what those folks do. And then we have, yeah, that's right, I heard about that. And reduced light availability for rootivascular plant communities. For us, Great Lakes, I guess, are pretty deep. Chesapeake Bay was a very shallow embayment, a lot of shallow water with rooted vascular plants. They're a really important part of the food web in Chesapeake Bay. So as you get the algal growth in the water column, then you shade out the rooted plants, so they die out. So instead of having these lush grass beds in shallow water, we basically have bare bottom. So those are important habitat for juvenile stages, a lot of juvenile life stages of economically important things. So just to give you a feel for, I'm used to speaking to a Chesapeake Bay crowd, so I don't usually talk about this, but just to give you a feel for the kind of the area. This is actually where the Y Research and Education Center is located, that red dot in the middle. And when you look at this, we call these rivers, we're located on the Y River, but this is really just a tidal bay. So I can look out my window and I can see tidal waters. It's got crabs, oysters, economically important estuarine species, and then I can look sort of a different direction and I can see crop fields. Literally, the way the shoreline is, there's literally thousands of miles of direct interface between cropland and tidal waters. Okay, so, but let me go to the next slide. So the general restoration strategy. So really, that's the slide that I talked about, the Bay problem, that was sort of pretty much laid out in 1981. Okay, there was a big EPA study. So in 1981, it was kind of agreed on in the scientific community that there was a big synthesis document done, and the main problem was over-enrichment with nutrients. In the late 1980s, there were some agreements signed. The first Bay agreement of multiple states in the watershed, basically, they set a rough goal of cutting nutrient inputs to the Bay by 40%. Maryland's sort of taking the lead on this. The way, you probably don't know the East Coast sort of state boundaries very well, but Maryland totally surrounds the upper part of Chesapeake Bay. So for Marylanders, the Bay is a central part of Maryland life. It's crabs, it's oysters, it's being out on the Bay fishing for striped bass, going back and forth across the Bay Bridge. It's a big part of Maryland life. For other states, and I guess you're going to deal with this in the Mississippi drainage, when people talk about the dead zone in Minnesota, talk about the dead zone in the Gulf of Mexico, this must be a hard sell to tell people you got to do this to fix the Gulf of Mexico. We have a little mini version of that in Chesapeake Bay, where folks in Pennsylvania and even upstate New York are being asked to do things as part of this Bay Agreement. So there have been lots of updates, and there's been lots of sort of political battles in this. So the problem on the land, always, our problems in the water almost always come back to things we're doing on the land. Basically, from an agricultural perspective, and what I'm going to focus on is our groundwater under our row crops, and we're almost like a mini slice of Midwestern type agriculture: corn, soybean rotation, some winter wheat and winter barley, but not a lot of pasture and hayland in the Delmarva Peninsula. Our primary livestock are chickens. Somebody asked me about that after the last session, so we didn't talk about chickens at all. And this talk isn't about chickens, but that is the end user of the grain primarily on Delmarva. So if we go out and just look at shallow groundwater, we have very little tile drainage. So mostly our groundwater, when I talk about moving through subsurface, I'm not talking about moving through tile drains. I'm talking about leaching into shallow groundwater and then moving laterally to a surface water body. So it's not as direct as tile drain. We don't have quite the short circuiting that you have in a lot of your watersheds. So basically, we get the high concentrations in groundwater, and then we're just pushing nitrate going directly into surface waters. Jim was talking about for phosphorus, the available forms versus the unavailable forms. Of course, the nitrate is totally plant available. Just to sort of show you a little data, this is some stream nitrate data from the interior part of the peninsula. We don't have the density of agriculture. For us, we start up to get up 60, 70%. That's a pretty high ag use watershed for us. We don't have the 90s. I've seen some data on some watersheds, and it's like, wow, 95% cropland in a watershed. We don't have that level, but when we get up to those two upper lines, we get up to 60, 70%. We're going to see 7, 8 milligrams per liter of nitrate on a steady basis. If you sort of go back to the late 80s, there are some people who have tried to piece together some very scattered data, sort of starting from World War II, and sort of it's been an upward trend from sort of like post-World War II up through the 80s, and we're really still even going up into the 90s. Now, if you look at that top graph, we kind of feel like we've plateaued a little bit on that. I'll talk a little bit about sort of why we haven't had sort of more of a downward trend for all the decades of effort. So some rough numbers for us: about 80% of our nitrogen is going from is we're losing from crop field is leaching into shallow groundwater. When we first started the Bay program, you sort of pull out of the toolbox what you got in the toolbox. In the toolbox in ag water quality in the 80s were erosion control. So what people were doing was putting in grass waterways, emphasizing reduced tillage, all the standard erosion control things. But if we sort of start breaking down our watersheds and looking at how the nitrogen was actually being lost, we could eliminate all the surface water runoff, and we really weren't going to get the big piece of the nitrogen pie. All right, so we had to get after the leaching part. The delivered load, this is actually reaching tidal waters, rough numbers about 20 to 30 pounds per acre. So obviously, you all know it all starts in the root zone. Just to sum it up, for us, basically getting our overall end loads down from cropland, it really boils down to getting the nitrate leaching rates down, which will lead to lower groundwater numbers, which will lead to lower loads in streams. Winter cereal crops do this very well. I'm really not going to concentrate on the details of the nitrate leaching bit with cover crops. We've had a fairly boring program, I would say. We're just using winter cereals, monoculture, I don't know what to say. This is just winter cereals take up nitrate. We're trying to get nitrate levels down. We've been promoting winter cereals. So that's really what we're after. We really haven't gone sort of the longer-term soil health, sort of the total environmental benefits package. This has really been focused on getting end loads down. To just look at a little data, this is kind of the data that's sort of driving that's sort of the foundation of the program in Maryland. This is looking at some groundwater nitrate. This is continuous corn. This is data from 2 side-by-side 30-acre fields at the center. Started looking at all the losses. These are actually watersheds that the surface runoff is monitored as well on a 24/7 basis. Started looking at nitrate and groundwater. This is what you'll see if you go out and people say, oh well, that's all in the research farm. But if we go out, we've done lots of coring and looking at shallow groundwater throughout the mid-Delmarva. You almost always will see groundwater nitrate concentrations above 10 parts per million under row crop agriculture. It's pretty standard. Those numbers back, I'm on the research center, so that was all recommended end rates. That was our farm manager was actually a very sort of almost on the tight side in terms of nutrients. So those aren't some wild optimistic end application rates. This was sort of state-of-the-art end management, split applications, some in the planter, and then the majority of it applied at side dress time. So we sort of put the pieces together about what we had to do. We started using rye cover crops after the 1988 growing season. Just the first sort of frightening year was the numbers all went up. But we have a couple years worth of water in the profile between the root zone and the water table. So we actually had a couple years of high nitrate water in the unsaturated zone that had to basically move through the system. So first 2 years, it gets you're sure it's going to work, but it's a little disconcerting to see the numbers going up after you start doing the practice that's supposed to make things go down. But anyway, as we start working with it and start moving the old water out of the system, replacing it with lower, like the data we've seen earlier about we know it's going to cut the nitrate in tile drain water. It's the same for leachate. And long-term, conservatively, we sort of feel like, and this is Cadillac. This is planting it right after harvest, using rye, no-till drilling. We're conservatively say we can get a 50% cut in our overall end losses. Just one sidebar that I thought I should probably mention, and it was mentioned earlier. You know, lots of people talk about the inefficiency of corn in terms of taking up nitrogen, but it's not so much that corn can't take up nitrogen very effectively. It's just for us, it's finished taking up nitrogen before our soils cool off. Okay, so here's a field where we have 140 pounds of N, fairly modest N application, yield 160 bushels per acre. This is great nutrient management. This is as good as we're going to get. And there's almost no nitrate in the soil when just about the time the corn's done. But corn stops taking up nitrate. We still have that warm soil. So by the time we get into our winter groundwater recharge period, we're looking at 20 to 30 pounds of nitrate in that root zone again. Okay, so we can't make this go away. We can't make this go away by tightening the screws on N applications. And then on soybeans, which is about half of our acres, and this is something we've seen again and again, soybeans grow a little longer. Soybeans pull down. Early in the growing season, soybeans don't take up much nitrate, so it accumulates, but when they go into pod fill, they're taking a lot of nitrate out of the soil. I mean, they'd rather take it out of the soil than fix it. It's preferential for them from an energy standpoint. I'm not a plant physiologist, that's what I've been told, so that's not my inside information. So anyway, so we see nitrate levels come down. As soon as they're done, then we see the same thing happen. The soybeans, they do shut down. Then this is 5 different years. We'll always see nitrate levels creeping back up after senescence starts. We plant soybeans after wheat. We have a long enough growing season, so we have double crop beans. I only have 1 year of data on this slide, but they mature later. So the later the crop matures, the later the creep starts, and the lower your numbers are going to be. So that gets back to the point of that period of no crops. We want crops out there as long as possible. So for us, this is a really important slide. This is just temperature. Sometimes the most basic things are really important. But for us, we look at our corn is basically done taking up nitrate about here. I mean, you know, it's going to vary from year to year about the spring and when the corn planting date was and how many heat units we had in the summer. But this is an average date for us, and you can see, you know, we're at black layer, and we're looking at soil temperatures still 60, 70 degrees. So we know our organic matters, you know, microbes are still churning along. So if you look at this, the good news here is if your crop's done then, you're going to have time to use a winter cereal too. So it's sort of a good news, bad news. You're going to have nitrate to deal with, but you also have time, a window to get after it. So what do we try to do? So we have the problem defined. We have the goals. So this is at the top. You see that says Table 2, 1995. Every tributary in Maryland, we had what we called. It was a big revelation that we're going to have tributary strategy. So every watershed had a tributary strategy developed in 1995, and every book had a Table 2. So if you go around Maryland and the old timers, we all talk about Table 2. Remember what it said in Table 2? Right. Well, so in Table 2, this is back in 1995. You see cover crops down at the bottom. And for this watershed, the chop tank, 50,000 acres of winter cover crops. And this was going to get 400,000 pounds. We're going to cut our delivered N load by 400,000 pounds. If you look at that column, that was we knew in 95 that this was the way to go for us to get our reductions. It's the lion's share of the N reduction we were going to get in that watershed. So for us, really, implementation is the challenge. We sort of knew, you know, or the science suggested they would work, but we really have just had trouble getting the acreage out there on the land. And just to sort of give you a little background on Maryland, this will probably, you know, you'll probably chuckle at this, but this is we are a little slice of the Midwest. This is our dominant crops. You see corn and soybeans, about 400,000 or 500,000 acres each. This isn't a region of Maryland or a couple counties. This is the whole state. So we have about 1 million acres, roughly 1 million acres of row crop land in all of Maryland. If we back out our wheat and barley, down here, if you add them together and say, well, we have wheat and barley, we have double crop beans. Obviously, our wheat and barley acres, they're not fallow, so we don't have to worry about those. Our double crop bean acres are pretty low priority. So we have about our goal would be, we're dealing with 500,000 acres going into winter with fallow. That was sort of what we were looking at as what we need to deal with. So how do we do on implementation? So this is going back to that chop tank watershed. As you go back to 1995, the goal was the red line, 50,000 acres. So that's where we were. So this greatly heralded Chesapeake Bay restoration effort that everybody wants to get done. We had our strategy, and we just went 10 years, and we never even got to half of what the implementation goal was. All right. So finally, in 2007, 2008, we finally have gotten to. This only goes to 2011, but we've stayed at that level. We've stayed at that level since. Things have changed. The bar has been moving around a little bit. Actually, now the latest goal was about 90,000 acres for the watershed. So but at least we've gotten to the first goal. So statewide, same sort of thing. We got 350,000 acres. Of that, 500,000 was sort of the goal. Not until 2011 did we finally get there. Now, before we go to the question of what happened, why did we finally get there, I want to talk a little bit about sort of the response in the delivered loads. So what really people care about is what they're measuring at the monitoring points in the system. So sort of like the MAW, you all know the MAW-ME. MAW-ME is your big monitoring point, that everybody talks about. For us, we have these, what they call RIM stations, or river input monitoring. And there's ongoing monitoring there to track the loads, the delivered loads. So this is not the model. This is actually measuring stream flow where it's delivered. That's what really everybody's looking for. If we look at, this is an actual cross-section of one of our research sites where we're looking at the travel times. And, well, there we go. We're looking at the travel times from the root zone, which the red line is sort of the bottom of the root zone, and the blue line is the water table. And we got a bunch of wells at this site, and this is our discharge zone. This is actually a tidal site where we've been doing monitoring to track groundwater flowing into the river, where it actually seeps in through the intertidal zone of the river. But anyway, the point being here is this is not a very big system. This is not like miles from the water. This is we're only going 160 meters, and we're looking at travel times from the root zone to the discharge point of like up to 10 years. Okay, so if we think back, we had our goals set in '95. We talked about we knew the problem in '81. We started talking about we were committed to restoration in the late '80s. We set up our strategies in '95. We met our implementation levels in 2010 or 2011, and we're looking at, on average, 10-year subsurface residence times. So this is really, we're testing the limits of the public's patience on this. Everybody's sort of, I'm getting old, I'm going to retire before, from the time the problem was defined, before we even got the first down. I'm not even giving up yet, but it is a little demoralizing. But anyway, that's a whole another issue. So this is an inland watershed, same sort of thing. We're looking at residence time. Again, no tile drains. So the red along the stream channels is 0 to 5 years. The average residence time for cropland in this watershed is about 16 years. Okay? So people will say, oh, well, it's 50 years. There are parts out near the water table divide. You see those dark purples where you're at a break point between two watersheds where there is really some old water down in there. If you want to go find some old water, the USGS guys can go out there and find some really old water and say, oh, it's going to be a century. But on average, we're talking about, a decade is not unusual. So that's sort of where we are on the timeline. I think I was asked the question of, well, are you seeing any progress, or how long is it going to take? So I thought I had to take a stab at that. So carrots or sticks? Everybody knows what I'm talking about when I say carrots or sticks, right? All right, good. So far in Maryland, it's been all carrots. Okay, I think the only sort of remote stick we have with cover crops is if you apply biosolids to cropland, there's a cover crop requirement. But for everything else, it's just carrots. For our farmers, we never really went the route of education on soil health and all those sorts of benefits. I mean, it's sort of been around. Ray Weil, he's been a big proponent of soil health benefits, but the overall push has been for water quality. I think our farmers, mostly the rank and file, big grain farmers, and for us, it's only a total of 1 million acres, but nevertheless, we tend to have pretty big operators. They do not perceive the winter cover crops as a positive bottom line, period. So we got the states involved. The Maryland Department of Agriculture runs a program that is basically to provide the carrots to get cover crops done. So if you look at that graph and say, well, what did you guys do? Did you do great education? Did you do? No, we basically got sustained funding for cost sharing cover crops. And this is Maryland spending. We're at $20 million. We got to $20 million. We have the first thing that happened, you see those first bump up, it's really been called the flush tax. So basically every residence in Maryland is charged an annual fee as part of their property tax bill. That was originally $30 per household, and now it's been doubled. So we got to $10 million, then we got to $20 million. So people call Maryland a socialist state of Maryland, or the tax and spend state, whatever. But we do have a political commitment, and the public is gripes, but they didn't throw everybody out of office. So we have $20 million. We have about a person for every 0.2 acres. Everybody in Maryland has about 0.2 acres of cropland for them. So we have a little bit of cropland per person, which is a sort of a scary thing. For me, I'm like, ooh, that's really bad that we only have that much land per person. But when you talk about collecting money to pay for cost share, it puts us at a really advantage because, this is basically $3 per person per year to pay for cover crops. So it doesn't seem so bad to me. But if you have, 10 million acres of cropland and 1 million people, then you got a different story. So, and then the other thing that happened was basically we've made the carrots bigger. You look at the first 10 years, we were bumping along at $20 to $30 an acre, and there were farmers, the sort of adoptants, you guys probably know better than I do. There's certain people who are easy to get in the program, and they sort of want to do it, and if you give them a little bit, they'll do it. They'll even put in some of their own money, and that's just some kind of scale where, the last 10%, you couldn't get them to do it, if you threatened to put them in jail. But that's sort of the general deal, I think. I don't know. That's my perception of dealing with people. But now we're up to about $50 an acre, and we've gotten pretty high buy-in. It's not really cost share anymore. It's actually black ink for most farmers. And so we've gotten the communication is clear. They aren't looking for more to do. They're very busy in the fall. So if it's just break even, they don't perceive it as helping them in the long term. Break even isn't even good enough. It's like, why should I go do something? I can just stop. I'm done. Then I can start working, getting ready for next year. So we're actually, I would say, pretty much in the black ink phase for a fair number of growers. So how's our cost share program structured? We try to sort of prioritize based on the science. Corn and vegetables are where we think we have our highest leaching potential. Manure certainly contributes to higher mineralization rates late in the season. And then we have priority watersheds. There's watersheds that the people who run the SARE model and things like that have sort of identified as places where the potential for high delivered loads is the greatest. We're also directed to the most effective practices. Early planting, no-till drilling, we use rye. Rye is the most reliable year in, year out as you push the planting dates later. But if we're trying to get high acres, you can't sort of demand perfection, and you can't say, we can only do it exactly the right way, otherwise you can't get in the program. We could never get the acres, so we have a lot of flexibility. Basically, every crop, there's some way you can be in the program with every crop that's an annual crop. We have aerial seeding. Works great when we get a nice big rain early in October. If we have a dry spell in October, aerial seeding is a little shaky. We have the radishes in, thanks to Dr. Weil. The verdict isn't totally in on them. They're very encouraging, but when people come in and say we think that there's evidence that this is positive, it's been put in the program and tried out. Vertical tillage as a planting method, so you broadcast the seed. Farmers like to do it as fast as possible, so they run over it with their vertical tillage device. Mixtures, we're starting to work into mixtures. We even have a program for wheat for harvest. If you don't fertilize it in the fall and you delay your spring nitrogen application until after a certain date, they do a heat unit calculation and say, based on you cannot apply before a certain number of heat units, you can actually get a subsidy for that. So they're almost trying to get a cover crop performance out of a production crop. And then it just is always, we're always sort of working on it. We have an annual meeting. We have farmers who want certain things, a group of farmers. We have the people who are doing the restoration, the watershed plants who want a lot of acres. And then the scientists are sort of stuck in the middle trying to broker something that you're going to get performance. You're trying to keep everybody happy. But you can't give the farmers everything they want, or you'll get practices that aren't effective. But unfortunately, the people who want a lot of acres, sometimes they're willing to turn a blind eye if they can say, we got another 100,000 acres. So it's sort of the scientists are stuck with saying, look, you have to do things that work. So lessons learned, look, farmers like to be good stewards, but the bottom line rules. They're businessmen, and that's what they are. They're businessmen. Implementation has to be high. This is one of those practices. This is not a silver bullet. You have to do it across a large percent of the landscape if you want to go down to some monitoring point downstream and see a signal. Be clear about our objectives. We're after water quality. So there's lots of good things you can do with cover crop, in terms of habitat for pollinators, whether you're going to use the radishes for subsoiling, all sorts of things. But you got to be clear about your objectives. If you're after water quality, then you have to make sure the practice is going to deliver the water quality objective. And then for us, we're already in the TMDL mode. So we have hard standards. Supposedly there's some teeth down the road that are serious if we don't have a strategy to meet the total maximum daily load. But for us, for in Maryland, we have this, we're encouraging things, we're targeting on a certain thing, but the Bay program system that's basically the TMDL doesn't necessarily credit things the way we promote things. If you're starting from scratch, I would encourage you to have the people who are going to sort of decide which cover crops are going to do the best job to be involved in both of those processes. So you want to pay a lot for somebody to do something. You want that to be the thing that you get the most credit for in the TMDL process. And then the last thing I would add on, I didn't have on this, and I would say accountability if you get into the cost share mode where you're collecting money using public dollars. Because for us, we've basically got the general public talked into providing funding for water quality benefits from agriculture. And they seem willing to do that as long as they have confidence that they're getting what they're paying for. So we can't make the program, we have to make sure we don't water the program down to the point that we want it to be flexible and farmer friendly and all that, but it has to deliver the product. Otherwise, we run the risk of, and we always have threats. People say that's $20 million, and they're just saying, what are we doing here? We can't be doing this. So every year, we're in this mode of justifying this transfer of money from the general public to the ag sector to meet this water quality goal. So you really have to keep the accountability into the program. And that's all I have. Thank you.